we couldn't like do that for like a football game.
Dude, I would have like totally vouched. All right. Did I put my? Oh, it's right there. Okay. So this one we're gonna do is gonna be a two-tailed test. Okay. Remember we did yesterday. Problem number 1 was the tail to the right. Problem number 2 is the tail to the left. This one's gonna be a tail that's two-tail. Does a new drug for migraines affect your heart rate? So being that you're looking for if it affects your heart rate, you're checking to see if it raises it or lowers it. God bless you. Everything is done the exact same way until you get your P-score, and then you double your P-score to see and test that against your alpha value. So does this rested heart rate for adults average is 55 beats per minute. So they're giving us this. So this is problem number 3 under 8.2. And then we have a sample of 20 people, and we found that taking this new drug of this sample of 20 people that the new average was 59.2, and then we found the standard deviation of our sample being 3.4. So this should tell you right away you're using a T-score. There are 2 main things to indicate. The most important one to realize is you do not have the standard deviation of the entire population. You have the standard deviation of the sample. So that says T-score right away. The other thing that stands out on this, please. The other thing that stands out on this is you are only using 20 people. Is that okay? So, create our hypothesis, and so our null is does medication keep heart same? The alternative, what we're testing is, does medication change heart rate? Change heart. Okay? So this would tell you by this right here, as well as using the word effect, this is going to tell us that we're going to use two-tail. Okay? And so what we're basically looking at it with a picture is something that looks like this. Area over here, area over here. Yes, we do have our mean in the middle. I don't know what the standard deviations are going to be yet. I mean, I know it would be 1 and -1, but I need to figure out what my t-score is going to be. So my t-value, I'm going to take 59.2, so what my sample's average was, and I'm going to subtract it from the entire population. I'm then going to divide by the standard deviation of the population divided by square root of 20. And if you go figure out this math, it comes out to 5.52. So this is basically positive 5.52 standard deviations, negative 5.52 standard deviations. So you're looking for above and below that. And then once we have found that, we're going to use the TCDF. So this is, we're just going to put our lower end, 1019. Now, on this particular problem, being it's a two-tailed test, I can either go the lower being the 5.52 and going to 1,000, or I could have it going from like negative 1,000 to negative 5.52. And then, where did the 19 come from, though? Subtract 1 from what? N. So that's your degrees of freedom. So if you do this math is going to come out to, it's going to come out to that. We're checking this. Our alpha is a 1%, so it's 0.01. If I were to double this, if I were to multiply this times 2, it's still going to be less than 0.01. Because if you multiply by 2, it would have came out to be like 2.5 times 10 to the negative 5. And that is still less than 0.01. which means we reject. We reject our null. Okay? Does the medication keep the heart rate the same? No. It's pointing to the indication that this is true. Okay? Even with just 20 people, our information is showing us that the medication will influence the heart rate. And that's kind of good math right there. I like it. We good? Too much talking going on. All right. Let's see. Number 1 on worksheet 8.3 says in 2011, the mean age for the deer population in Mesa Verde National Park was 5.97 years. Suppose that this past year, a random sample of 16 adult deer showed the sample mean age to be 4.39 years with a sample standard deviation of 1.82 years. Does this information indicate that the average age of the deer is lower from that in 2011 using alpha of 2.05? Okay, so this is problem number 1. So things that we know. We knew that by collecting data over years, this is what our average years old the deer was. We were looking at a sample of 16. Of our sample, we picked 16 of them. We found the average age of 4.39, and we found that our sample standard deviation is 1.82. Two things point to that we are going to use a t-test on this, and one is we do not know the standard deviation of the entire population, and 2, which isn't quite as important, we're only using 16 as our sample size. Okay, so create our null. Let's see. Deer age in Mesa Verde is the same as 5.97. And then my alternative, let's see. Does this information indicate that the average age of deer is lower? Okay, so lower, that's going to tell us we're going to go one-tailed test to the left. Deer age is less than this. My goodness. Sorry about that. Deer age less than 5.97. This here is going to tell us it's going to be one tail. This here is telling us it's going to be something like this, where that is indeed 0. So let's figure out what our t-value score would be. And then we can put in some more information. So we're going to take our sample average minus our actual average divided by 1.83, the standard, or 1.82, excuse me. Where's 82 times the square root of 16. This is going to find us a t-value of negative 3.47. So this is basically this. As far as your standard deviations. That's our t-score. What is the p-value? So the p-value, I'm going to use the TCDF on the calculator. I go negative 1,000 to negative 3.47. And I'm going to use 15, and the 15 comes from n minus 1. It's 1 less. It's your degrees of freedom. Why am I using negative 1,000? Why am I doing the lowered limit and not going negative 3.47 and going up to 1,000? Yeah, I'm trying to find the smaller, the lesser age. I'm testing if this is true or if we have evidence to prove or disprove that. So if I do that, this is going to give me 0.0017. And we are using an alpha value that was given in the problem of 0.05. So this is less than 0.05. This means I will reject this, which means it points to this. So it appears that we have a younger population, the deer age average population is indeed less. And we have to find other things. what does your conclusion mean in context? Dear age in Mesa Verde is lower than 5.97. We will reject the null. Go ahead and do that. Type of errors, it's probably a type 1 error. We know that, we actually know that H naught is true. Even though we just got lucky with the 16 deer that we guessed, that we know that the deer age is 5.97 is the average, and it happens to be true. It's just that we got lucky picking 16 deer. And I know some of you are going to ask, how do you know how old the deer is? Well, we asked them. Duh. Should be obvious. Especially when I'm writing D-E-A-R. Jeez, I'm sorry. Oh, boy, get out of there. All right, last problem for the day. Can you handle it? Anyone going to cry themselves to sleep? All right. It has been reported that the average daily hospital room charge is $687. A sample of 12 bills from the Manitou Springs Hospital. Oh, I said hospital shows that the average is 722 with a standard deviation of 5787. Does this indicate that Manitou Springs charge from the room is higher than the national average, uses 5% significance? Okay, so things that we know that this is from all of our information, the average of all the hospitals. We're talking about 12 rooms. We found that this came out to be 722, and we had a sample standard deviation of 57.87. Okay, our null. So guys and girls, I will tell you that on the test, we'll give you the null and you have to come up with the alternative, or we'll give you the alternative, you come up with the null. It's going to be pretty easy. I think there was one that you had to do both, but it's pretty leading. So the average daily hospital room is $687, and our alternative is the average daily hospital is more than that. Okay, this is going to tell us we're going to use a one tail going to the right. Okay, because we're looking for greater than. Other information we know, it told us to use a alpha of 5%. Is that okay? Everyone's attention. I'm sorry. I'm trying to make it only 3 problems. She's sleeping. Is she praying? Or is she on her phone? Not you. Is she sleeping? Yeah. Holman, what'd you rub it off on Abby for?
What?
Whoa. Oh, because he sleeps in here.
Yeah, you can't say that, man.
Okay. So why, Hoban, why does your
Oh my god.
oh sheesh. I'm sorry. I just realized what I said. Oh. Boy. And it's recorded.
I'm gonna go for a stroll.
He's out of here, man.
That's awful.
I'm sorry, guys. Oh, jeez. I can't win anymore. All right, sketch the normal. Get that. Gosh, I'm a horrible person.
Oh, man.
All right, so t-score is going to be used, obviously, because we don't have that standard deviation, and we also look at that. So t equals our whole average minus our average we found. You're right, Host, I'm sorry. I disrespected you. I hope you're okay. 57.87 is our standard deviation over the square root of 12. Do that math is 2.095. So you got 1 and then 2.095 for the most part. I missed it?
No.
Oh, that's possible. TCDF, if I'm looking for this, do I put an upper value that's big in, or I put a lower value that's small in? I'm looking for this though.
Oh.
Big TCDF. And I gotta go 2.095. 1,000, go big. And standard deviation being 1. If we do this, we're gonna get 0.03006. That is less than this. This just tells us we're using this as a standard deviation being 1. It means it's a normalized thing. We've created it to be a normal curve, and so it's, the average is 0, the standard deviation is 1. So we're ignoring doing this and this. Like technically, I could have this here and this here, but because we went with the t-score is telling us to go 0, 1, 2, 3, -1, -2, -3. That's why. We are going to reject this, which means we're starting to point to this. So the daily average hospital stay, especially in Manitou Springs, is more than $687. This could be a type 1 error. It could be we sampled not enough, or we just got lucky in Manitou and found the people that had the most expensive rooms for whatever reason, as far as their hospital stay goes, and that could have been for a number of reasons. So that's what I got, and a couple of you had a question on a calculator yesterday, and I spaced it. I didn't help you with it, so I will come help you with it right now.